In this first video of an exponential equation series, we're going to try and solve this equation. Now, when solving exponential equations, the goal is to try and find common bases. It won't always be possible, but that's the goal. So I know that 64 is 1 over 2 to the 6. Okay, so 1 over 64 is 1 over 2 to the 6. And then using rules of exponents, I know that 1 over 2 to the 6 is 2 to the negative 6. And once we get this, we're able to drop the bases, leaving with us just x equals negative 6. Okay, let's take another crack at an exponential equation. I'm going to start by isolating the exponential part of the equation by subtracting 3. Since those are both constants, let's combine them. That's 3 to the power of x equals 27. Now, I can start to look at, can I write these in common bases? And I know that 27 is 3 cubed, so that's 3 to the x equals 3 to the third, which means I can drop my bases, and I just end up with x equals 3, and that's it. Okay, let's start by trying to find a common base. It looks a little funky, but we can do this. 3 to the 5x, and it's clear that 3 will be our common base. So this is 3 squared x squared equals 3 cubed. Once we do that, we can distribute this in with the 2 and then combine these together. I'll do that in one step. So we get 3 to the 2x squared plus 5x equals 3 to the third. And then we can drop our bases, giving us 2x squared plus 5x. Subtract the 3 over to the other side so we can set up quadratic formula. So negative 5 plus or minus the square root of 5 squared minus 4 times 2 times negative 3 all over 2 times 2. Get 4 times 2 is 8 times negative 3 is negative 25 plus 1 is 49. That was negative 5 plus or minus 7 over 4. And gives negative 5 plus 7 is 2 over 4 is 1 half. And negative 12 over 4 is negative 3. And that is our solution. Okay, let's go ahead and take a look at another exponential equation where we can find a common base. We know that 4 is 2 squared, and that would be x squared minus 1, and still in the exponent, we get 2 cubed to the power of x. Let's go ahead and distribute our exponents and multiply them together, so we get 2 to the power of 2x squared minus 2 is equal 2 to the 3x. Now I'm going to go ahead and cancel the bases, and when I would set it up, I can subtract 3x to the other side. So I get an equation of 2x squared minus 3x minus 2 is equal to 0. Let's go ahead and set up our quadratic formula again. So that's negative 3 plus or minus the square root negative 3 squared minus 4 times 2 times negative 2 all over 2 times 2. We get positive that first, we get 4 in the denominator, we get 9 plus 4 times 2 is 8 times 2 is 5, 25 is 5. 3 plus 5 is 8, 7 by 4 is 2, 3 minus 5, and negative 2 by 4 is negative 1 half. And there are our solutions. Here's a problem I found online. I'd like to give my own shot at it. So I'm going to start by attempting to make this base 2. That's the common thing we've done in all my exponential videos so far. So that would be 2 to the 9. So 2 to the power 3, power 4, power x equals 2 to the 9. Now we have to use the exponent of x before we can use the exponent of 4, and so on. This is not the same as saying 2 to the power 3 to the power 4 in parentheses, okay? That's not applicable here. Okay, so let's go ahead and find out that we have base 2. Let's cancel that out. We get 3 to the power of 4 to the power of x equals 9, but we know that to be 3 squared, and we can take out another base. We get 4 to the power of x equals 2, and now we have to work on the left side finding a common base. That'd be 2 to the power of 2 to the power of x is equal to 2, and that gives us 2 to the 2x equals 2, which means 2x is equal to 1, which means that x is equal to 1 half. Remember that x being equal to 1 half is the square root. So if we go back to our original problem, 4 to the 1 half would be 2, 3 squared would be 9, 2 to the 9th would be 512. So my first immediate impression of this example is we cannot find a common base for 5 and 2. So this is where logarithms will come into play, and you can use any logarithm you want. I'm going to go ahead and use natural log, as that's my favorite, and we're going to use that to take the exponent down. So we get x times natural log of 5 is equal to natural log of 2. Finally, we treat natural log of 5 like we would any lead coefficient, and we divide by it. And we get x is equal to natural log of 2 over natural log of 5. Now you may feel that we should probably take a log base 5 of both sides. And that's a perfectly acceptable approach to this problem because we bring the exponent down and log base anything of itself will cancel out. So we're just left with the x and we get log base 5 of 2. Okay, so here we see an example. Do we have a common base? And the answer is no, we do not. So I'm going to go ahead and use the natural log to bring down the exponent. Now we'll have to be careful how we write this. Now the next step that we want to do is go ahead and distribute the natural log of 2. We're going to get 4x times natural log 2 minus natural log 2 is equal to, we'll distribute this, natural log of 3 minus x times natural log of 3. And what I'm going to effectively do in this next step is I'm going to take all the x's and move them to one side, and I will take all the constants and move them to the other side. Now let's go ahead and use some properties of exponents. Let's go ahead and divide by natural log of 48. And we get x is equal to natural log of 6 divided by natural log 48. And we are okay. I'm going to go ahead and start by multiplying everything times e to the x. This times this would give me e to the 2x, minus this times this would give me just e to the 0. That'd be 1. This times this. I'm going to subtract this over to the other side, 4e to the x. So I can set it up equal to 0. And here's why I'm doing this. If I rewrite this, e to the x squared minus 4e to the x minus 1, we have a quadratic looking equation in the form of e to the x. So I'll set up my quadratic formula. E to the x equals negative 4 plus or minus the square root negative 4 squared minus 4 times 1 times negative 1, all divided by 2 times 1. We get a positive 4 out of that first term. We get 16 plus 4 is 20, so that's root 20 over 2. 4 plus root 20 becomes 2 root 5 over 2, and then we can cancel, cancel, and cancel. We get 2 plus or minus root 5. Now, if you're okay with complex outputs, then 2 minus root 5 is okay, because 2 minus root 5 is a negative. If you plug a negative into a logarithm, you will get a complex number output. However, if all you're looking for are real numbers that give you real answers, then you just go with 2 plus root 5, and you are done.